Welcome students. Today we are going to start a new chapter in class 10 which is very important, and there are a lot of numerical problems and few techniques that you have to make yourself familiar with when you are going to go into some competitive exams, and also when you are going to go for your CBSE examination. These things will be very useful for you. So what I'm going to do in this session is I will be teaching you few important concepts that are associated with this chapter, and as a following of that I will also show you how different problems, numerical problems and some descriptive problems could be done completely based on this chapter. So first let us start with a very basic thing, charge. Okay, so what is electricity in the first place? Electricity is the one which is a basic necessity nowadays in almost everybody's home. So how an electricity is produced? Electricity is nothing but a charge that moves per unit time. So first we will basically study what the charge is and what are the different quantities and different physical quantities that are associated with the electricity, and then I will also be adding up few different things to it. First, charge. What exactly is a charge? Charge is an physical quantity. I cannot say completely a physical quantity. It is an intrinsic property of a material. Just like we human beings and all the other bodies in the earth has something called as mass. So like that, there is something called as an intrinsic property which is inbuilt on everything. So the charge is one of its kind. So the charge is of two types. One is positive and the other one is negative. So if these charges move from one place to another in a well defined path, that is when we get the electricity. So to begin with, we will talk about the charge. As I have already said, there are two types. One is positive, the second one is negative. So to describe the electric current flow, I will not be using the positive charge to describe it. We will always use the negative charge to describe the electric current flow. Reason is that it is not that the positive charge is not completely responsible for the current flow, but the negative charge was the one which was discovered first, and we describe all the physical phenomena only using the negative charge. That is the basic reason for that. And E is the symbol that I use to represent the fundamental quantity of a charge, where E is equal to 1.6 into 10 power minus 19 coulomb. So this is the basic unit, quantity of a charge. Okay, coulomb is the unit that I usually use to represent it. Both positive and negative charge will be having the same quantity in here, whereas the positive one will be represented with a positive sign and the negative charge will be represented with a negative sign. That is the only difference in the positive and the negative charge. So next one is the electric current. We will study about the electric current. What is the electric current? Current is not a term that is associated with physics, but current is a general colloquial term which is used to represent any bunch of things that moves in a well defined path. So here we call it electric current because the electric charges move in a well defined path. Okay, so I is the symbol that I generally use to represent the electric current, and of course it's a scalar quantity which is equal to Q by T. It is the charge flowing per unit time. That is what the electric current is, and the unit of this is coulomb per second, which is amperes. So this is the unit that represents the electric current. So, this being a basic thing, there are lot of quantities which could be measured based on the amperes, like it need not be amperes all the time. Suppose if your current is very small, let us say, then I will represent it as a milliampere, and I will also represent it as microamperes and something like that. So, these two are few basic things that almost everybody knows. Now, I am going to step into something that we used to use this particular terminologies in many places before, but most of the students do not realize what it is and how it works, and that is electric potential. That is electric potential. Yes, what is an electric potential? Just forget about the electric word in this, just think about only potential. What exactly do you mean by potential as far as the conversation is concerned? We know, we could say that this particular person is got a great amount of potential to do something. So, potential is basically means ability. Okay, ability of someone or something to do any particular things. So, here electric potential means the ability of the electric charge to do the work. For example, let me put it very clearly. As soon as you hear a word potential, the very first thing that should strike your mind is work. What type of work am I talking about? The work that is required to bring a charge from some reference point to a destination. I repeat, potential means it is the ability to do work for what? Bringing a charge from some reference point to a particular destination. So, that is called as the electric potential. Okay. So, generally electric potential is defined as V. V is equal to the amount of work that is being done per unit charge. See, the amount of work that is done on an unit charge to bring it from some reference point to the destination. So, that is how it looks. Next, the other term that you come across very frequently in this chapter is electric potential difference. Electric potential difference. So, we would have heard about this particular term frequently, but again most of the students are not physically clear with what exactly it does. Potential difference. Already we know what the potential is. Potential is ability to do work. Potential difference is the difference of the work. What do you mean by that? You see, let us say you are going to move a charge from this position to this position. Okay, I am going to move a charge from the position A to position B. So, what I will basically do is, I will find the electric potential at this point. You know what the electric potential is? The work done to bring a charge from the reference point to this point, that is VA. Similarly, I will also find the electric potential at point B, which is VB. Now, this being a potential difference, what I will basically do is, I will take the difference of these two, VB minus VA it is, VB minus VA it is. This is the potential difference between these 2 points, which basically tells you that the amount of work that you have to do to move it from A to B. That is what it means. The next very important quantity that you should realize is electric potential energy. What's an electric potential energy? You see, there are 3 terms that we have seen now. One is electric potential, next electric potential difference, now the electric potential energy. Electric potential energy. Okay. So what is an electric potential energy means? You see, this again represents the ability to do work, because potential is the term that is involved here. So what type of ability are we talking about right now? The ability to do work with the help of an electric field. Okay, it is the ability to do work with the help of the electric field. That is what it means. Okay, so basically electric potential energy will be represented with a symbol U, which is equal to Q into V, which is Q times V. Okay, this nothing means, this is nothing but the ability to do work with the help of an electric field. So likewise, now there is another important thing that we frequently study in this chapter, that is resistance. Okay, why? Because we know that by setting up a potential to a conductor, I can make the free electrons present in the conductor to move. Only if those electrons move in a conductor, electric current is produced. My next question is it possible to move the electric charges in the container without any restriction? No, it is never possible. Not only in the conductor, no, not anywhere else, you can just do something without a restriction. There will definitely be some resistance or restriction happening for anything that you do. So just like that, let it be a conductor, let it be an insulator or semiconductor, whatever it is, you will face a small amount of resistance or sometimes even a greater amount of resistance depending on the material you use. So how that resistance is monitored and what is the relationship between the resistance and the current flow is actually proposed by Ohm's law. Ohm's law. Most of the students will be actually familiar with the definition of the Ohm's law. What they say is the current that is going to flow in a particular conductor is directly proportional to the potential that is being set. Okay, the current that is going to flow into a conductor is directly proportional to the potential, but only if the resistance is constant. Only if the resistance is constant. That is why it is said as V is equal to I into R, where R is constant. Only in that case the potential is directly proportional to the current. So this is well known. So now what I am going to do is I am going to precisely concentrate only on this resistance down here. Resistance. Okay, as I have already said, resistance is nothing but a small amount of opposition that is offered by the material for the free flowing charges in them. So what are the different factors on which your resistance is going to depend on? Okay, so the first factor is the temperature. So with the increase in the temperature, the resistance of the material will also increase. Okay. Resistance increases with increase in temperature. Okay, we know this very well, and the equation that I use to represent the resistance generally is capital R is equal to rho into L by A it is. So this is the equation with which I usually represent the resistance, where L is the length and A is the area and rho is the resistivity. Rho is the resistivity. So the resistivity of a material purely depends on the nature of the material. Okay. So only depending on the nature of the material, the resistivity of it is decided. Okay. So now apart from temperature, there are also three other quantities that are in this equation on which your resistance is going to depend on. So now listen. The first one is the length. First one is the length. Okay. If the length of a material is greater, the resistance of the material will also be greater. If the length of a material is greater, if the length of the material is greater, resistance will also be greater. Then comes your area. The second one is area. What type of area am I talking about? Is this the surface area of a material? No, this is a cross section area. Okay. So resistance is inversely related. Inversely related to the area. And the third one is the nature, the resistivity. Okay, that is the resistivity. That purely depends on the nature of the material. So these are the three important factors on which your resistance is going to depend on, right? So this is for a material. Apart from this, we call something as a carbon resistance, which is a ready-made electrical component which provides the necessary resistance that we require to complete a circuit. So now, by arranging this particular resistance in different combination, we might acquire different resistance. I am going to show you how it works. First one, putting the resistance in series. So what happens if we put such resistance in series, and how to calculate the cumulative resistance offered by them? See, this is a typical symbol that I use to represent my ready-made carbon resistance. Across it, I will be connecting a battery, and I will also connect a ammeter to measure the amount of current that is going to pass through it. Okay, R1, R2 and R3 are the resistance of these resistors, and we know that the unit of the resistance is ohms. So now, what is the unit of this resistivity? Rho is equal to capital R into A by L it is. Capital R into A by L it is, which is equal to ohm meter. Okay, that is the symbol that I used to represent ohm. So now coming back here, my aim is to find the equivalent resistance of this combination. So how am I supposed to do this? Listen very carefully. If any electrical component is connected in series, then I am very sure that the amount of electric current that is going to go through them is same. Whereas the potential drop that happens across each and every resistor will be different. The potential drop across each and every resistor will be different. Okay. So, V is equal to V1 plus V2 plus V3. The sum of the individual potential drops are V1, V2 and V3. So, now I will slowly rewrite them from Ohm's law, where V is equal to I into R. So, V1 is nothing but I times R1, because current through all these three resistors are same, plus I times R2 plus I times R3. On the left side I will have I times R equivalent. So, all the I's will go down and R equivalent is nothing but R1 plus R2 plus R3 it is. So, this is the equivalent resistance for this particular combination. Similarly, let us see what happens if we put three resistors in parallel. So, what happens if we put three resistors in parallel? Listen very carefully. 1, 2, 3. So, we have three resistors that are connected across a battery like this. I will call this R1, R2, R3 into V. Clear? So, now I am trying to put the equivalent resistor for these three resistors. See, if any electrical components are connected in parallel, the current that are going to go through them will be different. Whereas the potential drop across these components will be same. So, keeping that in the mind, see I, this is I, this one will be I1, this will be I2 and this will be I3. Okay, so instead of numbering it like this, I will do it in a different way. So, now the current across these three resistors are I3, I2 and I1. So, now what I will do is I will just add all the currents up, where total current I is nothing but I1 plus I2 plus I3. Again using Ohm's law I will rewrite this. V by R equivalent is equal to V by R1 plus V by R2 plus V by R3 it is, and all the V's could be brought down, and 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 it is. So, this is the equation for the equivalent resistance in the parallel combination. So, these are the few things that you will be studying in this chapter, which is very important, and I will be showing you how different problems are being done using this concept in the next session. Thank you.